Good morning, everyone, and welcome to the AfPA webinar on high rep content in asphalt mixes. My name is Anna D'Angelo. I'm the AfPA Director of Technology and Leadership, and I will be moderating this session. Now, in this webinar, we will share, first of all, the AfPA model specification on the reclaimed asphalt pavement. We'll present the demonstration project that was undertaken in the city of cost using 40% RAP. And then we will touch on the sustainability benefits that can be achieved when we use RAP in our asphalt mixes. So I am going to share my screen now and start session. Okay, so and I'm just okay. So first of all, I would like to thank the sponsors of the project and also of this Ostrods and the City of Gold Coast Council. And also acknowledge the parties that have been involved in the project. So, Fulton Hogan for all the work to design, manufacture, and lay the asphalt mixes. RMIT University for the laboratory testing, and of course the three suppliers of the rejuvenators. Ingevity, JRS, and Stricker. Now, this webinar will end at 1:30 p.m. So we will go through a few presentations, and I will show the agenda soon. But just a reminder, please keep your microphone mute. And if you want to ask a question, there is a chat at the bottom of the screen where you can type your question, and we will address this at the end. It will be around 1:51 p.m. Okay, so here are the speakers for today. So we're going to start with Ian Clark. And Ian will give us an overview of the AfPA RAP model specification. Then I'll hand over to Warwick. Warwick Cutler is with Fulton Hogan, and we will talk about the demonstration project and findings and the testing that has been done. After Warwick, we will have three pre-recorded presentations from the rejuvenator suppliers. And I'm going to go through the details and introduce the speakers shortly. So first presentation, and I'm going to introduce Ian. And while I do that, Ian, please start sharing your screen. So Ian is the Downer National Technical Manager and joined Downer 1999 and held numerous positions focusing on technical aspects and also held roles in production, recycling, and transport. He has a strong focus on integrity and to ensure quality outcomes from the industry. Ian is currently the chair of the AfPA Asphalt Committee. Thanks, Ian, and over to you.
Thanks, Anna. Yes, so I'm here today to discuss the updated RAP model specification. So first off, I'll touch base on what RAP actually is. So RAP is standard practice across our industry. So we get our RAP from profiling asphalt surfaces or from waste in the construction process. But it does have significant environmental benefits, reducing the costs of bitumen and the aggregates. And furthermore, it goes into the environmental benefits. Because of that reduction of virgin materials, there are very significant CO2 reductions for every bit of RAP that is reused back into asphalt. It's good practice to use RAP back into asphalt and don't downcycle. By downcycling, I do mean like using for hard stands or for roadways just as a raw product. because the maximum benefit of RAP is back into asphalt, and it's not recycling, it's really reusing the same product over again. This specification is only on RAP, so it doesn't cover any other end-of-life products in this specification. So it has been updated in 2024 and shortly will be on the AfPA website. So it's going through the final approvals, but will be listed very shortly. It is this is really about the testing of RAP and how to manage the quality and percentages of RAP. So it must be used in conjunction with the RAP management plan, and each contractor should develop their own RAP management plans. This is really to try to promote the use of RAP and to assist people who are asset owners, specification writers, or end users. So it's really about the promotion of the use of RAP. RAP's been used for a long time, but as we progress, we're using higher and higher levels of recycled content. There are two main ways to introduce RAP back into asphalt, and that's the cold addition, and that's done through superheating the virgin aggregates, and generally it limits the asphalt plant to around a 30% RAP level. The newer technology is in Australia now, and there is a hot RAP addition. So that goes through a dedicated dryer and is gently heated up to the required temperature of 150 to 160 degrees. With this technology, it's possible to go up to 100% RAP in asphalt. There are three sort of levels of RAP. More or less defined as low levels is 15% or under, mid levels 15 to 30%, and higher levels, which is 30% plus. So we do need to treat RAP differently depending on what level of RAP we're putting into the asphalt, and I will go through each of them shortly. But the main testing is the bitumen content, particle size distribution, and moistures. And in the mid levels, we look at the virgin grade of binder. And then in the higher levels, we look at the RAP binder characteristics, as well as the final bitumen properties. So method one really looks at changing the grade of binder. Under 15% RAP, nothing changes. It's just the same as normal standard virgin asphalt. But once we go to 15 to 30%, we need to use a softer binder to counteract the stiffening effect from the aged binder in the RAP. So as per the table there, which is in the specification, if we were making a C600 class asphalt and using 30% RAP, we would actually change that C600 down to a C320. And then with the RAP added in, at the final grade would be a C600. But to achieve that, we need to use a softer grade. This is quite a good process, very simply to manage at the asphalt plant. It's just about what virgin binder we use. So it's very easy to implement. When we move over to method two, it does become a little bit more complicated. So we need to collect samples of the RAP and determine the binder content of that RAP, and then extract the binder from the RAP to test for viscosities, and then come up with a calculation blend. So through this blend, after we've tested everything, we then calculate out the combined viscosity of the asphalt blend, and we do have recommended limits that it must be in depending on the base binder. So the example that's in front of us is a C600. As you can see on the left-hand side, 0% RAP is right at C600. If we put 15% RAP in, keep in mind that we don't do any other controls, it does increase the viscosity, but still well within the range, expected range. And when we go to the 30% RAP, as per the method one, using a C320, we're back in the middle of that range. And it is possible in some cases, and depending on RAP type, at 40%, we could just substitute a C170 in and still achieve a C600 grade binder. Obviously, once we get up to 50, 60s, and 70% RAPs, that's when a rejuvenator will come into effect, and you'll hear more about the rejuvenators in the field trial after this. But we can then really design the viscosity to whatever grade by increasing the amount of rejuvenators. When we do our RAP testing, we have to break it into lots and control it. So there's binder content, as I said, aggregate size and binder properties. It's very important to have them in lots, generally up to 1,000 tonne, and test that well before production, again, depending on what RAP level we're going up to. The current limits in the updated draft specification is highlighted here. So we've got a standard proportion and a maximum proportion, but this specification really does allow up to 100% RAP is achievable, following the same principles out in this guideline. So it's about finding what level we need to do. But as before, 15% is sort of standard, but we're now proposing up to 50% RAP for light duty and even heavy duty asphalt. Modified binders, it is slightly reduced at 30%. And that's due to making sure that we don't dilute the polymers too much in RAP mixes using modifieds. But also SMA and open grade, traditionally, they have been always at 0%, but there is great opportunity to put RAP back into those grades of asphalt, as long as the grading and all those mixed designs works with the design. So it's now at 15%. And EME is currently working at getting to 30%, and that is being achieved in Queensland at the moment, and probably shortly we'll be looking at extending that as well. Non-conforming RAP, and look, in our industry, we will have non-conforming RAP, so we need to be able to use that in some way. So just because the RAP is outside of a grading limit, a binder content, it doesn't mean it can't be used. So the most easiest way to use it is obviously in a design with less than 15% RAP. It won't have that significant impact. It can be reblended, of course, but most importantly, it's what the final grade of bitumen is likely to be. So can we change our ratio of new binder to a different grade? Do we put more rejuvenator into it? And that's the importance of continually monitoring the lots. And, you know, the difference in the viscosity will affect the combined binder. So is it non-conforming marginally or a lot? All these factors come back into it. But all RAP should be reused back into asphalt. It's just how we actually treat that RAP before we use it. And that's all. Thank you.
All right, I'm back. Thanks, Ian. I'm going to invite now Warwick to share your screen and you can start your presentation. But first, just a quick intro for Warwick, who's been working with Fulton Hogan. And I will share my screen again. I've been working with Fulton Hogan in the laboratory for 16 years, and since 2015 has been the technical and laboratory supervisor. And I also want to add that Warwick has been very highly involved in all this project. So it's great that you can share with us what has been done. Thanks, Warwick. Over to you.
Thanks, Hannah. So this part of the presentation is about the demonstration project. So just as a bit of an overview, the project description was really leveraging the existing technology and deliver a broader advancement. So as Ian was saying, standard practice is 15, but we've gone up to 30. How do we get to 40? What do we need to do to actually put this into general use? So Fulton Hogan was asked to work in conjunction with 3 different rejuvenator suppliers, and we were asked to provide a suitable location where we would have 4 mixes. One would be the control mix, so a baseline to determine and something to gauge how the rejuvenators stacked up against the original. So the 3 different types of rejuvenators, so we had one which was a pelletized form, which we fed into the dry mixing process through a standard fibre feed, and then the 2 others were actually liquid. And we'll get back into some of that a bit later. So slightly different processes for the different rejuvenators in terms of production. So the site itself that was chosen the city of Gold Coast was a road called High Mix Road, Gavin, and it was leading up to a quarry. So it's had a substantial amount of traffic, a lot of heavy vehicles, about 90% of them. And the existing road was pretty much just a two-coat seal with CT base underneath. And as you can see, quite distressed, particularly on one side of the road. The baseline mix was the AC14H. It's TMR registered, standard for that contract, which is why we used it. Part of the process is obviously incorporating 40% RAP. You do desktop studies to make sure you can put everything together the way it should to meet the targets. We were running another trial in parallel with this one with a different client using one of the same rejuvenators, but different projects. So we did a lot of pre-testing in the lab with this particular project, just to make sure that we knew how to put it together. So lab trial testing, standard asphalt production, binder content, grading, the Marshall compactions, maximum density, and then we also did the TSR, deformation, resmods, and workabilities at 250 gyros. So on the right there, we've got the table showing the basic testing we were doing in the lab trials, standard council type mix, just showing really that the outcomes of a standard with the 40R with rejuvenators actually came up quite well within the lab. On the left here, this is basically the composition of the 4 different mixes when you put it into 100% inclusive of all the materials, as most plant computer systems do these days. Yep. So asphalt production, obviously you need the plant capability. We'd previously done trials a few years back for the city of Gold Coast using an AC20 40R, but that was a different binder for design philosophy. That was using a softer binder grade to get an outcome of C600. So we know the plant can actually produce 40 RAP without too much trouble, and indeed 30% is kind of a standard mix for us. You also need to know, obviously, your constituent materials, the RAP sources, the binder contents. And what we did in this particular case is, with the pre-testing we did in the trials in the lab, we saved those RAP lots, and then prior to the trials, we ran down the stocks of RAP and then brought in this particular RAP to use for the trials. We did a pre-trial just to make sure that our settings for production were on target. And then when we got into the trials, we actually dosed the liquid rejuvenators into the tanks. So in terms of production, what they did on site is they tried to keep all of the processes consistent between all the different mixes. So here we can see, just down the bottom here, we're using all the same equipment, the breakdown roller, Dynapack, CAT for the multi, and Dynapack for the finishing and back rolling. And we didn't change our processes between the different trials, control the 3 rejuvenators, and we kept the same rolling patterns. We did the trial during the day, so everything was pretty consistent in terms of the ambient temperatures. So that was pretty much what we did out on site. What I will say is too, that part of the distress of this particular road is we actually profiled out and put in a layer of EME first, obviously to give it that structural integrity. And then there was a tack coat that we went on before we did the wearing course at 50 mil. So these are just averages of the field results. We took calls from out on site. And as you can see, between the 3 different rejuvenators and the control air voids on the average were fairly consistent with good standard deviations. During the process of the production, we took box samples and they were sent off to RMIT for a number of tests. They included the compactability, TSRs, the ideal CT cracking test, which I don't know a lot about, but and then they also did Hamburg and several other tests. Now, I believe most of these findings will be in AfPA report. You can go through in a lot more detail on that type of information. So, behaviour of the mixes in terms of the air void content were similar with all the mixes. Moisture damage, none of the mixes showed really any propensity for moisture damage, ranging between 86 and 92%. And there was no real stripping observed in the Hamburg wheel test. The ideal CT test showed that the average index was in the range of 77 to 278. Notably, the 3 high RAP content mixes gave a lower CT index than the control mix. Fatigue resistance. 2 of the 3 high RAP content mixes were very similar to the control mix with the A15E straight binder. And that shows that if you get the dosing right, you can actually achieve the same as the control mix. In regard to the rutting resistance, the final rut depth was found in the range of 2.45 to 379 mil. And all of the high RAP mixes showed lower rutting than the control mix. This is a bit of calculation that Anna put together for me, basically just showing the GHG comparison between the reference and the alternative products. So the conclusion essentially is that in identifying the right content and the type of rejuvenator you wish to use is essential. You've got to do a lot of research in terms of finding out the right dosing of what it is, because if you get a dosing too low, you can get excessive stiffness and you can be prone to cracking. But if you get it too high, then you can have an excellent crack resistance, but you're going to get poor rutting.
Thanks, Warwick. I just wanted to add in regards to the AfPA LCA. So this calculation were based on the raw materials. So the plant was the same, and the calculation only take in consideration the raw materials. And you can see from the base mix, which was around the 33 CO2 equivalent per ton, that there was a reduction. So with the addition of RAP, we can reduce the carbon footprint. Now, as Warwick mentioned, there will be a report on this project. So, and this will be shared with the Ostrods, the City of Gold Coast Council, and potentially also on the AfPA website. So when is it ready, you will get a notification, and so you can look at all the details in there. Okay. So I'll now, so thank you, Warwick, and for that, I will stop sharing this screen, and I will now share another screen. So we are going to go through now another presentation. So this is now the turn of, let me close this one, trying to manage multiple screens. And okay, so, what is it? So at this point, I have 3 pre-recorded presentations that were prepared by the suppliers of the rejuvenators, so Sripat, Ingevity, and JRS. So I am going to share my screen and go through this pre-recorded presentation. And fingers crossed, everything works. So first of all, I would like to briefly introduce Krishna, who is the president of AfPA Technologies with over 25 years of hands-on experience in the bitumen industry. Krishna received his PhD in New York. He's a paving and roofing technology expert with a strong record of delivering cutting-edge, innovative portfolio of additives to enhance the performance of bitumen and asphalt. So I'm going to start the presentation, his presentation now.
Good day to all of you, and thank you for the opportunity. Before I tell you about Relixir Rejuvenator, I'd like to take a moment and acknowledge AfPA clearly for the work that they have done, not only in organizing the pioneering work in organizing the trial, HiRAP trial 2 years ago in 2022, but also the follow-up data collection and indeed bringing us all together today for the webinar to explore lessons learned and seek a path forward. So indeed, thanks to AfPA for that. So with that, let me tell you a little bit about Relixir. I'll start with the fact that it is a decade-old product with successful use by customers and contractors and transport agencies in North America, in Asia, certainly in Europe and South America. And now, indeed, hopefully with some Australian trials, we have some experience under our belts in the Australian climates and Australian continent as well. So this is what the product will be really composed of. This is what it does. This is the functional performance of it, but this is the main reason why it is considered. So I'll start and break these down one by one. It's a blend of bio-based oils, no burden on food resources at all, no recycled materials in it, all on-purpose materials, no VOCs, and a very low carbon footprint. And we'll talk about the carbon footprint and the sustainability in the next slide. Very efficient at low dosages, very, very easy to mix in a plant, non-hazardous, safe to handle, safe to transport, safe to use, and most importantly, works with a wide range of bitumens and RAP from our. What does it do? It restores the functional balance of properties in aged bitumen, in aged RAP bitumen. And by that, it means mainly improves fatigue resistance properties. It does all of that, but at the same time, it helps in reducing the amount of virgin bitumen loading into your mix. It helps with reduced virgin aggregates being added, and as a net result, delivers cost reduction. All our contractors, all our customers see some degree of cost reduction in high RAP mixes rejuvenated with Relixir compared to mixes made with no RAP or mixes made with low RAP. I alluded to this a moment ago, so this is kind of a quick capture. We have an extensive sustainability document and environmental product declaration, if you will, on our website, transparent. You can easily go and download it. And this captures one of the key elements of that report. This table captures one of the key elements. This is the kilogram of carbon dioxide equivalent released per kilogram of Relixir produced, and it is comprised of several different components: A1, A2, A3, and S1. A1, A2, A3 are raw materials, the transport of raw materials to the factory site, the manufacturing. The S1 number comes about because of capture of carbon dioxide from the atmosphere by the plant in the process of photosynthesis in the presence of sunlight to make the seed that is then used to extract the oils and buried on the roadway. So if you include all of these factors, you can see a net negative number, a net carbon capture per kilogram of Relixir used in your high RAP mixes. And there's much more detail available on our website. Please do check it out, shripath.com. So with that, let me shift gears and outline some test cases from pretty much around the globe. I'll start in North America. This is a trial for Illinois Tollway, written about extensively in Asphalt Pro magazine. And this is a challenging environment, extremes of temperature, cold and hot, very high traffic, arterial highway in North America. And they were looking at a 40% ABR. our mix. 40% of the total liquids in the mix comes from recycled content. And we looked at several different test cases. This was indeed a collaborative effort between a University of Madison in Wisconsin, certainly Shripath and the Illinois Tollway, the contractor Plody, as well as state testing, the independent testing lab hired by Illinois Tollway to assess the data, collect samples, and verify indeed that everything that we published is true and accurate. Couple of different test cases. One mix was treated with 1 grade softer bitumen. The other mix used the regular grade of bitumen, but 2% by weight of relixer. Standard balance mix design, you're trying to balance out competing properties, crack resistance, fracture resistance versus rutting resistance. How hard is your mix versus how soft is your mix? And you can see that the relixer dosed mixes comfortably met the specification values. In fact, they were pleased enough with this result, with the DCT or the crack resistance result, that they wanted to look at another sample. So we did make a mix and put it down on the roadway. They wanted a slightly higher amount of relixer to see if indeed they could improve on this number, the DCT number, while at the same time keeping the Hamburg wheel tracking or the rutting resistance in check. Indeed, we were able to do that and put down roadways with that. This is all mix produced, lab tested data. Just let me make sure. I want to highlight a couple of quick points. One is, I alluded to this earlier, the cost reduction potential. You can see that with 1 grade softer, with the softer grade material, you needed about 4.3% of virgin binder, and that steadily dropped as you increase the amount of relixer introduced or increase the amount of relixer in your mix. And the reason for that is relixer forced more and more of the aged bitumen in RAP to behave like virgin bitumen, thereby reducing the amount of virgin bitumen needed. The other thing I'll allude to very quickly is the aging result. Delta TC is a proxy for aging. You can see, and a lower negative number is better. You can see that the delta TC of the relixer rejuvenated mixes were certainly superior, trending in the direction of goodness, more aging resistance compared to the standard mixes, as well as mixes made with the 1 grade softer material. With that, let's shift continents. This is a trial roadway in Ireland, written about and actually presented and written about in the Irish proceedings, annual conference proceedings of 2023. 2 different mixes, one made with AC20 binder, excuse me, and one made with AC32 binder. And again, each of them tested 2 cases, the 0% RAP case versus the 60% RAP rejuvenated with relixer for both the AC20 and the AC32. And you can see that the properties are fairly comparable with the no RAP versus the relixer rejuvenated RAP. And indeed, that's the goal of all of our mixes for our customers. But the key thing I want to highlight is something that I alluded to earlier, which is the high RAP mixes with relixer helps reduce your carbon footprint. This was the first documented case where it was actually studied and reported. And you can see from this that the kilogram equivalent of carbon dioxide for both the AC20 and the AC32 mixes with high RAP, with relixer, were lower. And so this provides a net benefit to the environment. Switching gears again, let's move to another continent. This is a case of high base course material made with RAP. Control is a 20% RAP, and the experimental sample, the trial roadway, was 50% RAP. You can see that they use Marshall stability and Marshall flow as their criteria for selection and indeed verification. But I want to focus your number on the ideal CT. Ideal CT is another measure of fracture toughness, another measure of crack resistance, if you will. What you can see is, despite having very similar numbers on the Marshall, you're getting substantially better numbers on the ideal CT. And this is for 2 blends. This is the extracted PG grading data, so you can see that the properties of the 2 are close enough, but at the same time, you can see a sharply better ideal CT or fracture toughness number. And with that, let's come to the continent, great continent of Australia. A couple of trial cases. The first one is the City of Brisbane trial. This was done with M1000 binder. And again, we did test the no-wrap case. This is lab-tested data. But indeed, the comparison was between the standard or the control material, which had 15% wrap and no rejuvenator, versus 40% wrap and 3.24% by liquids weight, by total liquids weight of Relixer. Again, you can see the pen, the softening point, the viscosity, etc., numbers similar. I want to focus your attention on the CT index. And again, this repeats what we have shown you before, which is high wrap mixes dosed with Relixer while providing comparable performance to no wrap or low wrap, in this case 15% wrap, on a variety of parameters, are able to show you substantially better crack resistance, substantially better ideal CT numbers. And with that, let's come to the trial at hand, the City of Gold Coast. Two mixes made here, the control mix made with no wrap, and the high wrap mix made with 40% wrap and 4.9% by total liquids weight of Relixer. So that's the setting. These are the binder level properties. You can see a close match in the viscosity, the complex viscosity at 60 degrees, a close match in the continuous grade, extracted continuous grade, as well as a good number on the JNR. These are the mixed level properties that were put down. You can see the TSR, you can see the stiffness, and again, you can see a range of different properties, the fracture toughness and the crack resistance. But I want to focus your attention here on the fatigue number. A 4-point beam bending fatigue, you can see very similar results between the control case with no wrap and the 40% wrap case with Relixer Rejuvenator. So I just want to provide some closing remarks on Relixer, as this chart parametrically will tell you performance. This is one of our key requirements in pretty much every mix that we design, or we have our customers help our customers design. There should be no change in performance. Just because you're making a high wrap mix, it doesn't mean we should lower the standards. We do insist on it. We do work with the customers to ensure that the performance, both initial as well as long term, are comparable to what they are expecting from their low wrap or no wrap mixes that they're putting down every day of the week. I was able to detail for you how and why it is that most customers, if not all, see some measure of cost reduction in their high wrap mixes rejuvenated with Relixer. And finally, the balance, the impact on the environment, which is clearly a positive. Not only are you using more recyclable material in your mixes, but you're able to actually reduce your carbon footprint of your mixes. Thank you for the attention. Thank you again to AfPA for organization. Thanks to Fulton Hogan for running the trial. Many, many thanks to the City of Gold Coast and to RMIT and Professor Filippo for the extensive support and data gathering.
All right, so I've seen some questions coming through. The three speakers, so this recorded presentation, the speakers will be available at the end. So you can ask, you can type your question and we will ask them at the end. So I'm gonna move on with another presentation by Trey from Ingevity. And Trey is the EvoFlex Technology Deployment Manager at Ingevity Corporation based in Charleston. He has a bachelor and master's degree in civil engineering. During his 12+ years at Ingevity, his work has included research and technical support for what makes asphalt and product development for Ingevity's additives used in binder modification and recycling. He participates in several industry organizations and is a member of TRB's AKN committee and a board member for AMAP. So here is his presentation.
All right, looks like recording has started. Thanks so much for joining today. My name is Trey Worst. I work for Ingevity chemical company, and we talk a little bit about our EvoFlex rejuvenator additives. Today we're going to talk about EvoFlex used in high RAP asphalt mixtures. So yeah, we get started. First thing, just overview what we're going to talk about today. I'll talk a little bit about Ingevity and what we do. I'll talk about how a rejuvenator is engineered here at Ingevity. I'll talk about how we really design this to reduce the impact of aging in the asphalt binder and the mix. Talk about mixture performance. We'll talk about then sustainability reasons for using rejuvenators and kind of next steps from there. So let's get started. So Ingevity is involved in a lot of different things worldwide. Our motto is purify, protect, and enhancing everyday life. Make a lot of different products you probably use. All your cars, they have combustion engine, use one of our automotive activated carbon filters. So historically, when you go to fill up at the gas station, you have an empty tank with a lot of vapor, and that vapor is pushed out as the gasoline goes in, and that would escape your vehicle, and now our filters capture that. You see we're involved in coatings on all sorts of performance materials like wind turbines, airplanes. We're involved in agricultural ingredients to make insecticides or fertilizers more effective. We're involved in obviously asphalt pavement work to help reduce emissions with technologies like Evotherm, or use more RAP with technologies like EvoFlex. So we operate a series of refineries around the country, around the United States. We have what we call legacy crude tall oil business, where pine trees are for pulp and paper manufacture are broken down, and we take the oil out of there, the tall oil, and can use it in a variety of applications you see on here. We refine that much like a crude oil refinery. We also have now one refinery running on alternative renewable materials such as canola, which is rapeseed oil, or soy, or different materials like that we can also make these products out of. So it makes us really well positioned in the space to be able to offer different molecules that are most efficient at decreasing the impact of aging of the aged asphalt or the RAP binder in these asphalt mixtures. So how do we evaluate rejuvenators, right? So one of the key things we look at is what we call Glover row data. And this data really goes back to when we correlated ductility or cracking to DSR parameters, stuff we can measure on the dynamic shear rheometer. Glover has set these targets for initial cracking and block cracking, a certain number of pascals. Basically, this is a control PG64-22 binder. The orange bars are the rolling thin film of an age binder. Light green is 20-hour PAV, so we would say that's approximately 5 years of field aging, depending on your region, could be more or less. 40-hour PAV, so I think 10 years of field aging, and then the 60-hour PAV is 15 years of field aging approximately. What you see here is that 10 years, this binder is showing some initial cracking, and the blue at 15 years, we're seeing what we call block cracking or RAP levels. When we add these additives into this, we look at, can these additives impede the amount of aging happening over time, and can they slow that aging, really change the shape of the aging curves? So you see there's different additives for different purposes. A lot of the CA20 and 99 are very elite at reducing aging, reducing stiffness over time. You see the CA20, for example, here is CA9. This 60-hour aging is less than the 40-hour aging on the initial binder. So you're still not entering the RAP block cracking zone after 15 years of aging. So we look at this. This is what we would call a point parameter. So we're looking at the accrual of stiffness over time. Delta TC is something that shows us maybe our cracking potential and what we call a shape parameter. So as we look at binder, and the binder people on here, we typically would look at the low temperature calculation of a binder based on stiffness and the M value, or the creep relaxation parameter. And we'll check the difference between these two is all delta TC is. So it's just the difference in the critical temperature of the stiffness minus the M value. So minus 29.6, minus negative 28.4, Two negatives have a positive, so we end up with a delta TC of minus 1.2 in this example. So you can see the delta TCs here. Negative is more, negative is worse. So we want to stay above, depends on how much you age it, but at least in the 40 hour, we want to stay above -5. So all these are decent binders, but you can see as you add these additives, you increase the delta TC, reduce your cracking propensity. This is just in here for comparison. It's 4% corn oil to show what this would do. You can see all these engineered additives are doing a lot better inhibiting aging in this metric. So one thing to talk about here, how do these additives perform with actual RAP binder in the systems? It's one thing we look at. So you see in this example that we have binder A, binder B are actually the same, and so our binder C is just the amount of recovered RAP asphalt that's been added to these binders. So B has 20% and C has 40%. What we see going from A to B, 20% RAP, the binder grade at the low temp, at the 20-hour PAV goes about a 7-degree increase. When we age that further, in the 60-hour, we see a 12-degree increase. So the aging is picking up by adding more RAP. Our binder is aging significantly faster, is what this says. Well, when we add 4%, in this case of CA9, you see in this example, it is slightly softer out of the gate. It's 26, it's 31 instead of 26. So it's initially softens it, but you see a 5-degree increase when you add the RAP binder instead of a 7. So it's not aging quite as quickly initially. But where we really see a big bang for the buck is with the increase in stiffness with aging. So the 60-hour parameter, instead of increasing 12 degrees, we've only increased 7 degrees. So that's quite a change. Really, between the 20 and the 60 hour, we saw very little increase in stiffness, only 5 to 7 degrees, whereas the without the additive, we saw a 5-degree shift instead of a 2-degree shift. This shows how impactful these additives are in reducing aging, the impacts of aging in RAP binder systems. We've done work with this in different BMD projects. This is an example from a state on the East Coast of the United States called Virginia, where they have a 5828 binder and 40% RAP, head-to-head with a 6422 binder, 40% RAP, and 2% rejuvenator. So one of the mixes was made at 150C and then compacted at 135C. Another mix was made, though the rejuvenator mix was made at the same parameters, and then both of these mixes were made with about 15 degrees C reduction, mixed at 275 or 135C and compacted at around 120C. So we see here the next chart shows us 2 parameters. In red, you have your Homburg, your rutting parameter, and in blue, you have your CT index. So you can see the rutting as we soften these mixes with combination of reduced temperature with warm mix and increased rejuvenator. We see the rutting go up a little bit, but this is really not a very rut prone mix. So 2.5 millimeters to 5 millimeters is insignificant in the rutting performance. What we do see is a real increase in the CT index. So we go from a 76, just turning the temperatures down 15C, bumped our CT index up 30 to 40%. So that's pretty exciting to be able to do that. And then taking this mix and adding rejuvenator bumped up the CT index. And the combination of the two is the most powerful on here at increasing the CT index. So it's really cool to see both the rejuvenator additives and warm mix having a big impact on these RAP mixes and being able to get the correct cracking index number to indicate superior performance for this state. We do have, switching gears a little bit on sustainability, we do have EPDs for these additives, a number of these additives. This is the EPD for EFLEX CA9. All these additives are made from plants. So as the photosynthesis occurs to create these trees or plants, they capture carbon, and this is entrained when we harvest the oils out of these additives. So these additives, when placed in asphalt, give a carbon offset because of the biogenic carbon material in these additives. This is shown on these documents. If you go on Ingevity's website, ingevity.com, and go to our sustainability page, you can request these documents, look at the carbon footprint reduction of these different additives. But yeah, we make these products from a variety of different sources. I've already talked about some of these are made from canola, some soy. Traditionally, a lot of them are made from tall oil. We're able to blend these different ingredients to hit the and to engineer these additives to perform like we want in these applications. So this is we think these additives really have a place going forward of helping increase our RAP contents and still maintain our cracking performance like we want. We know that increasing the RAP can dramatically reduce the carbon footprint of the asphalt mix. And I think this is a real opportunity for contractors and agencies out there to utilize these more and more in the next 5 to 10 years. But I appreciate everyone listening today. Thank you so much for having me talk about this. We'll take questions at the end of the session. And Dane Taylor, who'll be on the call, is our business manager in Australia. And his contact info is on here if you'd like to reach out to him. Thank you so much.
All right. So next, last but not least, and I do want to thank people that have joined from the States and from Europe. I know that the time is not great for you, especially I think in Europe, it's very early in the morning. So thank you so much for joining us. So I'm going to introduce Jens. Arnold is a civil engineer since 2016, product manager at JRS, and is responsible for Northern Germany, Scandinavia, Benelux, and France. He is a member of various working groups of the German Asphalt Pavement Association and the German Road and Transportation Research Association, involved in rejuvenators, temperature reduction, warm mix asphalt, innovation, rubber modified bitumen and asphalt mixes, and is a member of the AfPA, which is the European Asphalt Pavement Association working groups, and specifically in the task force for the reuse of reclaimed asphalt and task force warm mix asphalt. So here is the presentation.
Ladies and gentlemen, first of all, I would like to thank the AfPA for giving me the opportunity to share some hopefully interesting and useful information about our rejuvenator Viator Plus RST with you. Within our company JRS, we identified two mega trends for the future of our roads. The first one is the one I'm going to talk about a bit in detail, is reclaimed asphalt pavements in new asphalt mixes. The second one is something I'm not going to touch today, warm mix, half warm mix, respectively, cold mix. So what are the drivers for using RAP in new asphalt mixes? The first approach should be the environmental one, so saving natural resources and saving CO2 emissions. The second one for sure can be the technical side, so bitumen shortages, whether a refinery has a shutdown, planned or unplanned, or the crude oil selection of the oil companies. And the next one, it's a real crucial one, is bitumen quality, due to the fact that the refineries have more and more sophisticated techniques to get the most out of the crude oil. In the meantime, the bitumen quality decreases. So in many cases, the quality of the bitumen inside the RAP is superior to the quality of the virgin binder. These saving money also can be taken into account, but definitely should not be the main driver for the incorporation of RAP in new asphalt mixes. So how to increase RAP content? Of course, you should know what your RAP is and what's inside your RAP. So the type of binder which is used, is it a modified binder? If so, which type of modification is used? At least carrying out some basic binder properties or tests, softening, point, ring, and ball, which should be kind of indicative to somehow identify the degree of aging of your bitumen. Simply, you should know what is inside the RAP. So for the time being, we are ignoring the mineral aggregate additives or what can be inside. So crumb rubber, is it eventually recycled plastic, or is it threaded cables? We in JRS have a very clear thinking about these three additives, so-called, which I stating here. These additives will definitely turn asphalt trash route. Very clear thinking that those additives or materials should be used better, rubber back to tires, recycled plastic bottles back to plastic bottles, and shredded cables back to cables, but not dump it not in our asphalt. Because just 1% of this as an addition to the asphalt mix, so 10 kg automatically create 1,000 kilogram of trash salt, and the generations following us need to get rid of this material. Beware of softening agents or recycling agents, then, because they definitely can just lower the viscosity of the H binder. They definitely cannot reactivate it, and they are just softening, diluting, or plasticizing it. So how to overcome the binder aging, which automatically leads to the potential of increasing asphalt mixes? Better should use a sustainable and effective rejuvenator, which restores both the physical and the rheologic properties of the binder. It reduces the overall viscosity. It can reduce viscoelastic properties, and definitely that should not lead to accelerated aging of the rejuvenated binder. Last but not least, also soft bituminous binders can be seen as recycling agents because they have the same parents, so to say, but even the softest binder is not as close to the efficiency of rejuvenators. In our case, for our rejuvenator, it is 10 times more efficient than the softest binder we are allowed to use in Germany. So, to give you an idea how to differentiate between rejuvenators and recycling agents, I'm using the black diagram. The virgin binder is the black curve. Once this virgin binder gets aged, it turns the orange curve. So the compact shear millers went down and the phase angle is going down also. And by just plasticizing it, so using recycling agents or softening agents, we're just moving this curve downwards. We have no impact on the phase angle, and that is really crucial. By using a real rejuvenator, you shift this orange curve back into the direction of the virgin binder. You're lifting the phase angle, and then that is a clear indication that this additive used is a rejuvenator and not a recycling additive. So our Viatop Plus RC, the tests we conducted before aging, after aging, and after further aging can be divided into the physical tests that you can see here, softening, point, needle, and needle penetration. The more sophisticated tests, rheological tests, DSR, so dynamic shear rheometer, BTSV, and the bending beam rheometer, which addresses the low temperature performance of the binder. The philosophy behind it is, on the left-hand side, you can see the virgin binder PEN 5070 with 100% performance over the entire temperature range. And on the right-hand side, you can see the H binder PEN 5070, and it lost all the performance over the entire temperature range. And by adding either a softener or recycling agent or a rejuvenator, you then should see how parts of this temperature range are restored. This particular case, there was used a softener or recycling agent, and especially for your climatic conditions, you can see that the high service temperature range hardly is not restored in any case. So low temperature is okayish, medium service temperature is okayish, but that is what really is of interest for you. The high service temperature range is not restored. So that is completely different if you check the results of the binder modified with our rejuvenator Viatop Plus RC. You have a very good performing restoration of the properties over the entire temperature range. just to give you an idea how we are determining the amount of rejuvenator to be added. In this particular case, we are doing this calculation the softening point binder of the softening point ring and ball. That is just an example, and the outcome or the amount to be added strongly depends on the content of the rep binder, on the properties of the rep binder, how much of rep you want to use. That is gets into the calculation to finally determine how much of our additive you do need for the resulting asphalt. Sustainable and effective rejuvenator, that is what I was touching. Our Viatop Plus RC rejuvenates the H binders regardless of the stage of oxidation. It's a green product by nature, made of natural raw materials. It is non-water polluting, it's highly efficient, it can reduce costs, higher addition rates of RAP are possible, conserves the natural resources. You can make use of the existing dosing equipment for fiber pellets, and definitely no need for investment in any tanks for liquids. Here are some examples of successfully realized projects in Europe with RAP contents above 50%. Some of them are done for sure in Germany, and others are done just few examples in the Scandinavian region, in the city of Helsinki, Holding, which is in Denmark, of Stockholm, the capital of Sweden, and it was used in binder, base, and wearing courses, and even in SMA making. The project on the Canary Islands in Spain, on the Tenerife airport, the taxiway was renovated, and the taxiways are heavily trafficked with stop and go, so even more than the standard runways. 25% of RAP reduced, in total 100,000 tons of asphalt mix, and that was really critical because the airport authorities are sometimes very reluctant in testing new things. I think that was explained in depth. The Gold Coast project with a RAP content of 40%. The tests they were conducted, you can see there. Almost all the results confirmed that the same or even better quality compared to the control mix generated by the use of our Viatop Plus RC. So, to cut a long story short, the JRS way towards sustainability. We are innovative, we are economical, we are environmentally friendly, and we are durable. So we are Viatop Plus RC. Thanks a lot for your attention, and I hope you're doing well. And feel free to ask some questions to my colleague who will be present during this presentation. Thanks a lot.
That's excellent. So we are now we now reached the end of the presentation. So I am going to go through the questions in the chat, and if you have more, please feel free to type in there. I would like if the speakers here want to turn the camera on, so we can, yes, Warwick, so Ian, and also, I don't know who is here from Ingevity, and Sripat, and JRS. So I'm gonna go and start with some of the questions. So here. So first of all, I'm gonna go through the easiest one. Yeah, there's one from Hamid talking about if these rejuvenators function. So do these rejuvenators function as soften only, or do they also alter the composition of the aged bitumen? Horst has already responded, depends on the rejuvenators. Some products are called rejuvenators without rejuvenating, and they should be called rejuvenators. So if anyone wants to add anything on this point, feel free, and happy to hand over to whoever wants to add anything to this point.
And
you want us to respond, Anna?
Yes. Do you want to add anything, Ian?
Yeah, I was just going to agree with Horst. There is obviously rejuvenators aren't all equal, so every product has to be investigated. Some are pure softening points, others rejuvenated age binders. So that's the purpose of this research and suppliers to do their due diligence.
Thank you. Okay, so one of the first questions was, is the reclaimed two-coat seal pavement included in this technology or just asphalt? So what we discussed today is asphalt. So we do recycle asphalt. So at this stage, I'm not aware of recycling spray seal. I remember something in New Zealand or some ideas around that. If anyone wants to add to this, again, happy to give you some time.
Yeah, I agree. Today was about asphalt, so generally seals aren't recycled back into asphalt. It depends on the quality of the seal and quantity of the seal, but it can obviously be recycled back into other treatments for roads, but generally not back into asphalt.
Great, thanks. Ian, Joe has a question about the DSCT. DSCT results suggest a lower crack resistance for high rep mixes. Was this first investigated? So I can answer that one. So the project only included the analysis of the asphalt mixes that were laid. So we haven't discussed the next steps. So if there is anything else that needs to be done to understand a little bit more or additional tests. So at this stage, this has not been investigated. Another question about does the GHG comparison include other additives, polymers, rejuvenators for the FH work? So the comparison that we've done, and I might call Nobe for help here. So that was done with the LCA, the AfPA LCA calculator. And we included the information about the EPD that we had available for one product. For the other products, we did use the Australia LCI. So it does consider the use of these rejuvenators. Nobe, if you are here, do you want to add anything?
No, thanks, Anna. No, I think you've covered it all. That it's yeah, the outcomes are reflective of the inputs that were provided and using the standard LCI database that's currently available.
Thanks, Nobe. So do I have a Horst on in the line? Do I have Horst? Because there is a question about how you quantify environmental friendliness. And I see someone, I don't know who answered this. We use a natural bio-based rejuvenator. I can't see the speakers, so I'm not sure who's. I don't know if it's available. Oh, no. Frank, you did this. Yes.
Good morning. Yes, I answered this question. Yeah.
Yes.
So that we use a natural bio-based rejuvenator for our Wire2 Plus RC, and that's why we regarding this product as environmentally friendly.
Okay, thank you. Now there is another one. So I asked the Fulton Hogan people maybe, Would the EME2 be influencing RAP mix designs in the future down when pavement rehab is done in decades to come?
Not quite sure of the context of that question. Can you say it again for me, please?
Okay, so the question says, would EME2 be influencing RAP mix design in the future when pavement rehab is done? Really, it's in the chat.
I can probably answer that if you like, Anna.
But I don't think it would. But anyway, yeah, go ahead, Ian.
Yeah, obviously EME generally has a high viscosity at production stage, so it will impact. However, with rejuvenators, we'll be able to reduce that back, and highly likely in decades that when we're doing this, we'll be putting it back into an EME, so it'll probably benefit those mixes. But it is something that we'll have to monitor and watch when we are profiling those mixes and how we use.
Thanks, Ian. Any further comments?
Yeah. Can I comment?
Oh, hello. How are you? Yes, please.
It's not that dark here because I'm traveling in Asia, so it's not that early in the morning for me.
Right.
Regarding EME, I think EME is just another asphalt mix, and why shouldn't we be able to include RAP in just an asphalt mix? It's bitumen, it's aggregates, it's filler, and unfortunately no virus, but that doesn't matter at the moment. But we can definitely use RAP in EME, and I think we should start that discussion with the inventors of EME, talk to the French specialists. The French experts should know, because I think the first EMEs in France have to be recycled or reused at the moment, after they have reached the end of their life cycle.
Mm-hmm. Yes. Thanks for
comment, Anna.
Well, yes, Krishna and the host, and if there's someone from Ingevity, I have a question for you about this the rejuvenators. Now I lost it. Where was it? It was about how you quantify the environmental. No, there was another one. Sorry, I'm just trying to find it. Okay, yes, that's in all standards. Carbon sequestration in growing plants should not be included unless the CO2 is sequestered for about 100 years or more. So what is your comments on this?
I think that's a fair. This is Krishna from Shripath. Several points on this, and I also want to make a comment on the EME aspect in a moment. But the questioner is correct. Everybody has a different standard. For example, NAPA in the US, the National Pavement Association, Asphalt Pavement Association, at this moment, they're considering it does not allow calculation of biogenic contributions. Europe does. Australia has to make up its own mind. It is still an evolving field where people are beginning to ask the question, what contributes burying the carbon, capturing the carbon and burying it. And so, yes, we will have to wait for standards to evolve, but for thinking to evolve on this matter. On the other question, and I want to make a quick comment about the EME, and I want to echo what Horst said. EME is just another binder. And as examples, I showed an example of the Illinois Tollway where they use RAS, recycled asphalt shingle, which is probably decades more aged than EME binder. So with the correct rejuvenator, with the proper dosage, good mix design, it's possible. I suspect it will be possible, not only in the very long term, but immediately, even in the shorter term, to design with the RAP EME mixes.
Wonderful. Thank you, Krishna. I see Trey there. Trey, would you like to Ingevity to add anything?
Sure, just real briefly. Can you hear me okay,
Yes,
Anna?
very good.
Yes. Yeah, I just agree with Krishna on the biogenic carbon. That was well said, that the different countries have different rules. In the US, the carbon sometimes gets counted, like in Europe, they allow that counting of the biogenic carbon It depends on the land usage, though, right? You can't just take a rainforest and strip it and start growing biomaterial and get credit. It depends if that forest was sustainably managed for periods of time. So yeah, it's something Australia will have to set and how they want to do it. But yeah, Chris is also correct that the Napa tool doesn't account for that right now. That'll be something they review in 2 years when they redo the product category rules. So
thank you. And do you want to add anything around that comment on the rejuvenators? Is they function as a softener or alter the composition of the aged bitumen?
yeah, I think that's true. I think you can. It's hard in the compact time slot to dig into the asphalt chemistry specifically, but there's SARA analysis people use to look at that, the asphalt chemistry, and then trying to understand the aging of the binder. I think the two things that are important, and maybe looking at the mixture performance long term is maybe more indicative than trying to pick the right test to break it down on the front side. So. There's certainly more that can be looked at there for sure.
Thank you. I have a comment from Steve. Steve talked about cold process. What about a DG with C600 and 25% rep, bumped down to C320, but made as warm mix asphalt at 135 degree? Should we use a rejuvenator to get the rep mobile considering lower temperature of virgin aggregates? Is this question clear?
Yeah.
It would depend on the mix design, Anna. For me, this is a difficult question to answer because we need to know details of the mix design and details of the specification that the author is looking to target. In theory, it's possible, and in many, many instances, yes, even in practice, it's possible. But we will have to, before I can make a comment on that, I need to know specific mix design, incoming raw material properties, final desired specifications, etc. In theory, it's possible, yes.
And Trey, you were adding something.
Yeah, no, I agree. I think the question is targeted around that reduced temperature might help the mix design get closer to some sort of target metric, kind of like Christian was saying. So I think that's very possible. But yeah, it's probably have to get more specific looking at the specific design. So
thank you. All right, I don't have any further question related to what we're talking about. So unless you have anything you wanted to add, I might just close here. Anyone who wants to add anything or last comments? I definitely would like to thank the speakers for today, and also the speakers who pre-recorded the presentations and are here with us today. So thank you for your help, for your support. These presentations the presentation will be available. So if you want to go through the slides again, they will be available on the AfPA website soon. So since I don't have any further questions, I might just close here. How does it sound? Okay. All right. Well, thank you again. Have a great day and see you soon. Thank you.
So,
thank you.